Hi everyone, myself Harsha. I am PEGA trainer at Harsha Trainings. So all of you, welcome to Harsha Trainings. So learn PEGA in depth, all the concepts at its best. Okay. In this video, you're going to learn about Q processor and its detailed explanation. Before we go to the video, so a small announcement that we are going to start PEGA training new batch starting from 31st May of this month, and that is starting from next Tuesday. Timings will be morning 8 a.m. to 9 a.m. So we have two modes of sessions like classroom and online live sessions. So anyone from anywhere you can join PEGA training like online mode, or if you're from Hyderabad, you can join classroom training. And the course duration is 3.5 months. And we are going to cover from basic level to advanced level, covering two real-time projects. So one will be taught in the class and the other one is going to be given as like an assignment for you to work at your free time. Call us on the number that is shown in this video for any training inquiry, and we are going to show you job opportunities on PEGA, as well as we will help you getting the jobs even if you have career gap after your education. Now let's get on to the video. So let me explain you about Kafka. Okay, just a high level, not in detail. Okay, we don't need. It is already designed in PEGA. I mean, like this design is already present in PEGA. See, Kafka is a message broker. Kafka is a message broker. It deals with handling the messages. It will have the messages. Okay. Now messages will be processed. Messages will get processed. See, every input is going to be a message. See, you are using LinkedIn platform. So you are dealing with so many communications. There are so many conversations that is happening, right? So this conversation messages all will get processed through Kafka. See, LinkedIn has made an announcement. So that announcement message will be delivered to all the LinkedIn account holders, right? Means from one place, the message has been processed and delivered to multiple different places. For example, I'll tell you. See, you have a broadcasting service, right? Let's say Dish TV is a broadcasting service. So Dish TV is a broker here who is going to take the details of data about the channels. Like there are different channels, right? Like Star Channel, ATV, and many other channels are there, like Discovery. So these channels will be individually supplied or broadcasted, are being provided by individual vendors. What is the Dish TV is going to do now? This acts as a broker in between. It collects all the messages from all different channels and it is going to broadcast to the customers. Whatever the channel you subscribe, there is a term called subscription. You subscribe to a channel, only that channel will be broadcasted to you. Okay, this is the concept of message queues here in the Kafka. Kafka is a broker now. It will take the input messages and it will be broadcasted. Whom it will be broadcasted to? Everyone. Whoever is going to subscribe, the messages will be brought. Suppose if you are going to unsubscribe for the notifications, you turn off notifications. Are you going to get notification message? If you subscribe only, you will get. Like what happens in the reality, like you are taking a dish connection. Okay, when you take a dish connection, you are going to subscribe for different channels. There will be a supplier, right? Service provider. Service provider is going to give it to broker. Broker is going to broadcast it to the subscribers. The same way, Kafka message broker is going to have the input messages being delivered and placed at that broker place. Broker is going to send it across. So who is the subscriber here? Like LinkedIn, you have so many messages. The messages will be going through the Kafka broker, message broker, and message broker is going to deliver it to the subscribers. There is a way it can deliver. Subscribers can access it to take it. That is also possible. Okay, so this Kafka message broker has been developed by LinkedIn itself. LinkedIn has developed it long back, and later they have handed over this Kafka message broker to Apache. The company Apache, they started enhancing it like as per the need in the market. See, processing a database record and processing a message in an enterprise system, processing a message is faster than database, but database has its own purpose. Database is a permanent storage. Message will go on temporarily. Ultimately, you have to store the message in the database if you want to store it permanently for the later purpose, but only during processing. So you want faster processing, you can retrieve the messages quickly from message queues than tables. So considering this fact, PEGA has come up with a design of using the Kafka message broker here in the queue processor concept. In the queue processor concept, PEGA is going to use Kafka message broker. Here that is Charlotte server, something is there. Okay. And where all the queue messages, all the queue items, whatever the work object that you are going to push, like in standard agent, when you push a work object by using queue for agent, it will make an entry into table as a table record, picking the record from table and processing it. That will be done by standard agent. Now the design is like, when you queue an item to queue processor, a work object is being queued by run in background shape. Then this details will be queued into message queue for the Kafka broker. Understand everyone? It is not a table entry. It is not a table entry. Look at here. PRPC personal edition folder on the server, Tomcat, Kafka data. You see here, there are many queue processors available OOTB in PEGA. Update case status like this, even maybe I would have created it, or PEGA standard processor, and I will tell about this PEGA standard processor in some time, and PEGA attachment queue processor, PY send email queue processor. See, for each queue processor, you see how many partitions. These are called partitions. Total how many partitions you see? PY send email 0 to 1 2 3 4 till 19 means total how many? 20 messages can be taken at a time by the queue processor and it will process. This is what we discussed yesterday in the before video. The maximum number of parallel threads to run by queue processor, how many? 20. So 20 messages will be processed at a time. It doesn't mean only 20 you can push. You can push more than 20, but at a time from each partition it will take, let's say, one message, and overall it will process 20 messages parallelly. Suppose queue processor is running on 4 nodes. Each node 20 it can process at a time. Total how many it can process parallelly if it is running on 4 nodes? 80 at a time it can process. But in case of standard agent, it can process only 4. Means 1:20 is the ratio. Now one message it can, one item, one work object it can run and process. Here how many we are processing now in the same time? Parallelly 20. This is the advantage of queue processor. Coming up with the design of message queues, the advantage is they have achieved parallel processing of 1:20 compared to standard agent, plus processing will be faster. Processing also will be faster. Who is going to do that processing, taking the message queue item from the message, and where does the processing happens? I'll show you. Okay. Now you go to PRPC environment, records, sysadmin. There are OOTB queue processors available. Where is it? Queue processors available. See here. I don't know why PEGA standard processor is not been shown up here, but leave it. See here, you see batch indexer, process case event, PY send email is there. The moment you create, suppose this is already available, means it would have been created by someone, right, who has developed PEGA. If I create a queue processor, the moment you create queue processor, within a few minutes, it is going to create 20 folders like this. Okay, 20 folders like this. These are data partitions. These are data partitions. In each partition, it will have message. It will have message like this. For every queue processor that you have, you should be seeing the 20 partitions being placed here by the process commander. So how this design is being done, we don't need to bother about, because PEGA has internal design of doing all this stuff. Everyone clear? PEGA has internal design of doing all this stuff. It will create for each one 20 partitions will be created, and you have 20 messages to be picked at a time and processed at a time parallelly. Make sense? Everyone clear? Next step. See here. So every message that is going to enter here will not have any physical storage. I mean, when I say database storage will not be there. This is what is the storage here? Hard disk, some folder, and this one. This will be handled by whom? Message broker. What is the broker name here? Charlton or something is there. You can Google it once and see. Okay. And now see here. This queue processor, let me open the queue processor. Queue processor is going to, generally I am taking this option by default. Immediately it will process, means when a queue item enters there, queue processor will pick it and process it. See, and when it is going to process, it will run this activity. You have a facility to mention the activity in the queue processor. Like standard agent, you are mentioning an activity, right? Same way you'll mention an activity here. So whenever there is a queue item enters into message queue, that will be picked and processed by the queue processor, and it is going to execute the activity for the queue processing. So when queue processor wakes up, usually it takes 30 seconds internally, wakes up, it will look up the message queues. Standard agent, when it wakes up, it will look up the queue table, right? Now queue processor, when it wakes up, it is going to look up message queue. And if there are any new messages in the queue, we cannot see that messages and all. It will be like different format. It will pick the message, means it will get the work object data, and it will execute the activity for processing. Once done, that message will be removed from the message queue, and the commit will happen internally, even though there is no database. Okay, that commit will commit whatever the changes that you have done in the activity. Okay, so this is what going to happen when you're dealing with queue processor at a high level. Everyone clear so far? Now you see here. See, system message queue processor. See, every queue item that you are going to queue, it is not a physical instance in the database table, right? It is not a physical instance. Just give me 1 minute, please. Just hold on a minute, please. Later. Okay, fine. Okay, so let's go ahead now and let me restart. See, every queue message is going to stay in a hard disk. It is not a database table to say it as an instance. See here, immediate processing, right? It will enter into message queue when run in background gets executed. So look at here, run in background shape. I'll open and show you. Run in background shape will ask the parameter. What is the parameter? It will ask you what is the name of the queue processor to which you wanted to push the queue item. So I'm going to go ahead with dedicated queue processor. One message will enter into the partitions of the respective queue processor. Into this queue processor's partitions, a message will be entered. Suppose that is immediate option. Suppose I have chosen the option delayed. Now queue messages will not enter into message queue. If I choose this option, queue messages will enter into a different place. See here. See, system message queue processor delayed item. There is one class. Let me go to the definition of this class. And in this class, scroll down and click on test connection. This is connected to a table. Now it is a table instance. PR_sys delayed queue. Whenever you use run in background, whenever you are pushing a queue item to the respective queue processor, system will verify this queue processor is an immediate option or delayed option. Immediate means this queue item will enter into message broker message queue partitions. If it is delayed option, then it will be made as an entry into a database table. What is the table? PR sys delayed queue. Delayed I have given, but how long? What is the duration of delay? Look at here. The duration of delay is going to be like in minutes. 1 minute I have given, otherwise 10 minutes I will give. The moment it enters into delay table, it will stay in the delay table for 10 minutes. After 10 minutes, it has to be processed, right? It will not be processed from table. Queue processor will always process messages from message queue only. After 10 minutes, that record will get deleted from the delay table. It will made an entry. It will be made as an entry into message queue automatically. Automatically after 10 minutes, it will be made as an entry into table called made an entry into message queue, message these partitions. But who is going to do this task? There should be someone to do this task, right? So now see, for a standard agent or whatever the agent we have, we discussed about master agent, which will monitor all other agents, and it is going to note down the scheduled time intervals, next wake up time and all. Accordingly, it will wake up the agents. The same way here, for the queue processors to be up and running, there is something called stream service. What is it? Stream service. Stream service. See here. As long as the stream service shows execute option, it is up and running. Suppose if I choose that option stop, it will get stopped. It will get stopped. So this stream service monitors all your queue processors. It will make sure that the queue items will be processed accordingly. The stream service queue processor should wake up and process this queue items and all. And after 10 minutes of delay, the record from the delay table will be pushed into message queue. Who is going to do that? Stream service is responsible for doing that internally. Okay, it will note down everything. Okay, now message queue, message will enter and then it will process. Once the processing is successfully done, the queue item will be removed from the partition. It will be removed from the queue message, will be removed from the partition. There is a failure in processing. You know, right? We worked on a standard agent. If there is a failure in processing the queue item status will get updated from regular now processing to broken process, right? And we discussed already. You go to admin studio. In the admin studio, you are going to look at the broken item, select the broken item and requeue. In the previous session, I told you how to requeue also. There is one more video available in YouTube channel, how to requeue broken items for standard agent. See, in case of queue processor, it is not a database record to change the status and all. It is a message queue message item. See, the failure messages will be taken out from the message queue and will be pushed into another table. I'll show you the table name. What is the table name? Broken items. See here how many broken items are there? So many. Definition, and here test connection. So PRC's message QP broken items. Now in the broken items table, you have messages as a database table record. How to requeue those items? Look at here. So first you need to go to broken items. How many broken items are there? N number. The broken item, whatever you want, open it. Okay, see here. It is going to show some XML information. I'll show you. Look at here. Admin studio, resources, queue processors, and any queue processor. This queue processor, you see how many broken items are there? 2. Click on this broken items number 2. These are the broken items. You just click on this arrow mark and view XML. Like standard agent also, you click on that, it will show XML form. Error. You have error details. As a developer, you should be able to go through the error message, understand the message. Based on the error, you need to find out the fix and fix it. After you fix it, what you should do? After you fix it, these items are been, errors are been fixed. Now these are there in which table? QP broken items table, right? PRC's message QP broken items table. Select the item one or more, whichever is fixed and you want to requeue it, and click on requeue button. Click on what? The moment you click on requeue button, the item will be taken out from broken items table and will be pushed into message queue, data sets of message queue partitions. Now queue processor will pick from the message queue and try to process. If again failure is there, it will be removed from message queue and pushed into broken items table. Everyone understand the concept how it will work? This design, which has been developed by PEGA systems, it has far better processing with respect to speed, with respect to performance, with respect to parallel processing, the time. All of these, they have achieved better results using this particular design of using message broker. And having this design implemented, they renamed standard agent into queue processor. Simply speaking, overall, if you leave about this design, both are doing the same. It will take a message, it will take a queue item and then process. Okay, but how it is been designed in the background, that is what we need to know about. So let me summarize queue processor up to this so far what we have discussed. Queue processor is an instance of class system. Rule async queue processor. Okay, and a queue processor, when you create, you can schedule it to run immediately or delayed. Delayed means you need to mention the delay time, 10 minutes or 1 minute or 5 minutes or 20 minutes, like that. And if it is immediate, the queue items which we are going to push by using the flow shape run in background, or by using a method. In the activity there is a method. Let me show you the method. Dev Studio. Any queue processor related activity I'll open, and not queue processor, generally other activity. Okay, queue for processing. Here itself it is queue for processing. If you use this method during the activity execution, also you can queue for processing method you can use, or you can use run in background flow shape. And now while using, you choose your own queue processor you created, you choose dedicated and mention the name of the queue processor. When work object reaches that flow shape or this method in the activity, an item will be queued into queue of queue processor. What is the queue here? Message broker. There will be data sets and there will be partitions. In the partitions, this work object data will enter as a message. Queue processor, if it is immediate, it will pick the message and process. If it is delayed, when you push the queue item, it will go into delayed table. PRSys queue, PRSys message. What is the table name? Delayed items. Into that table, it will make an entry. After 10 minutes delay is done, suppose delay is 10 minutes, it will be re-queued into message queue. It will be done by stream service. As long as stream service is up and running, your queue process will run. Stream service, if you stop, none of the queue processor will work. Okay, so that means going to monitor the queue process. And next step, after this, your queue processor can be mentioned as when queue processor is processing the queue item, if there is any failure, that message will be taken out from the message queue. It will be pushed as a record into a table called PRSys message QP message. What is that? Broken items, you know. What is the table name?
PR message.
Hold on. PRSys message QP broken items. That is the table name. Into this table. Now, broken items, you can go to admin studio and go to queue processor, and in the queue processor itself, it will show the number of queue items which are broken. Click on that number, click on the queue item, you will get XML format of data. See the XML format of data and try to see the error message, fix it, and select the item and click on requeue. The moment you click on requeue, from broken items table, the record will be removed and made an entry into message queue, and queue processor will pick it and process it. Everyone clear? This is what we have discussed. And furthermore, you see here in the queue processor, you have something called delay factor. Delay is, I have given, let's say 5 minutes. Delay factor is there. By default, the value of delay factor is 2. See here, this delay factor is used to calculate the period between the next retry attempt by multiplying the previous delay value by the factor. With the default initial delay of 1 minute and delay factor as 2. Initial delay is how many? 1 minute. Delay factor by default 2. The delay sequence is 1 minute, 2 minutes, 4 minutes, 8 minutes, etc. Maximum calculated wait time is 24 hours. Let me tell you this calculation. 1 minute is the delay time, for example. And what is the delay factor? 2 minutes. I have mentioned delay time is 1 minute and 2 minutes is the delay factor. So by default it is always 2. Now you push the queue item to queue processor. Now it will enter into delay table, right? What is the delay time? Actually 1 minute. But what is the delay factor? 2 minutes, right? Now 2 minutes, that is 2. You can understand 2, not a minute, 2. Now initially when it is being pushed into delay table, it will be there for 1 minute. After 1 minute, it will be pushed into message queue. Now queue processor will try to process it, right? There is a failure in the process. There is a failure in the processing, right? Now it will be made as an entry into where? Usually broken items, right? Usually it has to go to broken items. But instead of that, you see here maximum attempts. I have given 4. Means when a failure happens, instead of putting this record message into broken items table, keep it into delay table only. How many times it has to do like that? 4 times. When a message processing is failing, it will be kept back into delay table. Delay table it has to wait, right? What is the delay time I have given? I'm sorry, 1 minute I have told you, right? Usually it has to wait for 1 minute. For the first time it waited 1 minute. Now it is retrying. At the retry, 1 minute into 2. What is the time? What is the delay factor? 1 minute is delay time. 1 minute into delay factor is 2. How many minutes it will be delayed now? After 2 minutes of delay, it will be pushed back into message queue again. Now queue processor will try to process. Imagine it is again failed. Now it will be put four times, right? I have given retry. Now it will be again pushed into the table called delayed items. Now it has to wait for some time, right? How long is it going to wait? What is the previous delay time? 2 minutes into 2. What is the time now? 4 minutes it will wait. After 4 minutes, it will be pushed back into message queue. Again, third time is also failed. Now it is fourth time. Now it will again put it into delay table. It is failed. Sorry, it has to wait for some time in the delay table, right? What is the time it has to wait? Previous delay time is 4 minutes into 2. 8 minutes it will wait there. After 8 minutes, it will be pushed into message queue. Now again there is a failure in the processing. Again, now 4 times completed. This is 5th time. 5th time it will be pushed into broken items table. So automatic retry, I mentioned 4 times. 4 times it will retry. Means it will first time when it is failing, it will go to delay table, wait for the delay time into delay factor for the first time. First retry. Second retry, previous delay time into delay factor. Third time previous delay time into delay factor. Fourth time previous delay into delay factor. 5th time it will be pushed into broken items table. You need to go to broken items and then find out the issue, fix the issue and requeue it. Understand everyone clear? Automatic retry plus initial delay plus delay factor. These 3 everyone clear? Every one of you online. Everyone clear? Respond on the charting window. Okay, so this is about delay factor in queue processor. Now one important point about queue processor I have to tell you, that is while you are trying to push the queue item into queue table, either by using a method or either by using flow shape called run in background, you see there are 2 options. Listen to me carefully. There are 2 options. One is dedicated, another one is standard. If I choose dedicated, it is asking what is the queue processor to which you want to push the queue item. It is asking. So now for this queue processor, it is going to push the queue item, and within this queue processor, it has an activity. That activity will get executed for processing purpose. Understand everyone? Clear? Every one of you. Dedicated means your own queue processor, or any queue processor that is being created by you, or maybe any other which is OOTB available by PEGA, except a standard queue processor. I'll tell you what is standard queue processor. Now, apart from this, I'll show you now by flow shape. Both are same, method and flow shape. Instead of dedicated, if you choose standard, when I choose standard, is it asking for any queue processor name? It is asking for activity name. I have given activity 1. See, when run in background is executed, I am trying to queue it, but I am trying to queue to standard. where it will get queued? That is a question. See, if you are trying to push a queue item to the queue processor, there should be some queue processor to receive it, right? If I use dedicated, it is asking what is the queue processor to which you wanted to push the queue item. But if I am using standard, it is not asking for any queue processor name. Instead, it is giving activity name. That is also not mandatory, optional. Activity also optional. To which queue processor it is going to push the queue item? Look at here. See, there is one OOTP queue processor called. There is one OOTP queue processor by name PEGA standard processor. PEGA standard processor. This is the OTP queue processor. This queue processor also will have an activity. It will be there. Okay. Whenever you push a queue item by using either run in background or queue for message, and if you choose the option of standard, then your queue items will be pushed into the message queue of this queue processor. This queue processor will process. Then you wanted to write the logic of activity as per your requirement, right? But the activity is OOTP provided by PEGA, and you see this is a final rule. You cannot modify it. We save as into your rule sets. Then that's why PEGA has come up with one option. What is that? Activity. I am giving one activity here. The queue item will be queued to standard agent. I have given activity 1. At the time of processing queue processor, at the time of processing the queue item, it will execute activity 1 instead of this activity. The activity which you are passing will override the activity that is present within the queue processor. Understand? What is the advantage of using PEGA standard processor? What is the advantage? See, you don't see. Suppose you are being given with a requirement. For that, you need to create 3 different processings. So you have created 3 different queue processors. 3 different queue processors will have 3 different activities, right? You push the items to queue processor 1, queue processor 2, queue processor 3. How many queue processors you created? 3 you created. 3 different activities. Instead of creating your queue processors, suppose, but that has a limitation. Number of threads are 5. You want 20, this doesn't work out because it is a final rule. You cannot override. I want only 5 threads per node, and I want a delay of, I want it to be processed immediately. I want it to process immediately, and maximum retry items 3. When your requirement adhere with all these values, then only you will go for standard agent. I want 20 threads. I want a maximum readiness of 5. I want a delay processing. Then does it work out? Can I override this rule? Is it possible? Why I cannot override? This is a final rule. Instead of this, I will create my own. Okay. But if your requirement has everything in place which is matching with standard queue processor, immediately processing number of threads 5 and then maximum items 3, then you don't create queue processor. You call this queue processor by using the option of standard, and only activity part you have to write. Activity you mention while calling. See here, while calling you mention the activity. Now PEGA standard processor is there. For that queue item will be pushed. That queue processor, when processing the queue item, it will run activity 1 instead of this activity, instead of the activity which is there in queue processor. Now for 3 different requirements, you just need to create only 3 activities, not the queue process. Understand? Everyone clear? Only activities you create, don't create queue processor. But if your requirement has 5 maximum attempts, 20 threads per processing, then does it work out using PEGA standard processor? Doesn't work. You have to create your own queue processor. So PEGA is trying to avoid allowing the developers to create their own queue processor with some standard values. Okay, try to make use of it. Don't create by yourself. At the time of pushing the queue item to PEGA standard processor, PRPC will ask the activity name. The activity which you provide there will override the activity that is present in the standard processor of queue processor. So far, everyone clear? Online resources. Everyone clear so far?
Yes.
Okay, let me tell you little more details about queue processor. So we discussed about queuing the item, delay item, broken items, requeue, standard as well as dedicated options. Everything we discussed, and I have shown you the message queue, Kafka, data sets, partitions, all that place where to see. Processing has to be done, right? So queue item will be picked and processed, right? In order to process these queue messages, PEGA has come up with by using a flow, that flow will get executed and processing will happen. That flow is called as data flow. What is the flow called as? Data flow, which is under data model category. Okay, I will show you. See here, admin studio, and this is the queue processor, right? For this, whenever you create a queue processor, in the background, system will automatically create a data flow. System will automatically create a data flow. You can see that here. View data flow. It will open in developer studio. So you don't need to see the flow shapes and all. Just the rule. Just what is it going to be done? I'm going to show you. This is the data. So this is the data. The data flow with the same name has been created. And you see here how many input records it has processed, how many input records successfully, and how many failed. All that will be shown here. Okay, everyone clear? So a data flow will get created in the background, and data flow is responsible for processing the messages as a data sets. It will process all the messages as data sets. That is how internally processing is happening. Everyone clear with this point? Online resources. A queue processor processes its messages by running a data flow in the background. If you go to the data flow, you can see all the details. Understand, everyone clear? So this is how data flows looks like, but it is the design, like they might have done so much, but here it is going to process the data as a data sets. Just to show you the diagram, this is an abstract source. Find out something. See here, suppose for example, I'm telling. So there is something called data set. If you're going to process data set, it will process the records in the data set. Data set is nothing but some table. Okay, I mean, like, it's not physical. Okay, it's a format of data. Message queue data will come and be processed through the data sets, and that data will be processed successfully. Okay, or maybe it will fail also, and it will be done by data flow. Just for your information, that you can see when you go and click on open data flow, it will be shown up here. Okay, you can see. Everyone clear? Online resources. Warnings we don't need to bother. So this is overall about queue processor concept. Okay, so as a developer, you are learning so much in the background design and all, but for end users, they don't need to bother about it. Simply, if you want to work on practical requirement, you don't need to think about all this stuff. You just create a queue processor and use run in background and push the queue item. What happens in the background, you have to learn if you want to become a good developer. Okay, so that's it for now, and we are going to practically work on this queue processor requirement, same requirement.